Hi. So in this video we are going to discuss to how do we decide the optimum value of k. So consider this particular example where we have visually we can see that there are three clusters we are having. But let's say we take the number of clusters as 2. Okay, so we take this as one cluster and this is another cluster. This is the centroid of first cluster and this is the centroid of second cluster. Okay. Now what do we do is both clusters have their own centroid. What do? We calculate the average distance of all the data points from the centroid. For example, let's talk about this cluster. Now what we are going to do, we are going to calculate the distance of each data point of this cluster from its centroid. Okay, and then we are going to take the average of all the distances. Okay, so we take the average of number of points and distance of number of points. Okay, we take the average and that is the process that we repeat for all the clusters. We calculate the average distance between the data points from their centroid. In cluster 1 it is very clearly visible that the average distance is going to be much higher, right? So now let's take clusters equal to 3. Now if we calculate the average distance between the data points and the centroid, then we can very clearly see that there is going to be a massive reduction in the average distance of the data points from their centroid. Okay, and if we increase clusters furthermore, then this basically see this another cluster has been formed. Here again the average distance is going to decrease for sure, but the thing is the reduction in the value is not going to be of that significant value. Okay, the thing is that increasing the number of clusters improves the accuracy of your model, but the thing is when you increase the clusters the computation also increases. Okay, so your goal is to find that balance between the computation power and the accuracy, and that is what we do here. So now if we keep on increasing k, the average distance will decrease, but the rate of decreasing will keep on going down. Okay, so we have to find that optimum value for k, for which we have the maximum impact, and also we are saving as much computation as we can. Okay, so for that we plot a graph. On the y-axis we have the average distance, and on the x-axis we have the number of clusters. Okay, so initially here we have 1, here we have 2. So initially when suppose we have one cluster, then the average distance is going to be much higher. Then we increase the number of clusters, then the average distance is going to go down, and then we again increase the cluster, then it is going to go more down. But one time a certain stage is going to approach where your graph is going to bend, and after that when you increase the number of clusters there is not going to be much significant change in the average distance. And this particular curve is called as elbow curve, by the way, because it resembles an elbow. It looks like an elbow, and the optimum number of clusters for your model is actually the point where this elbow is achieved. This is the point where you have the optimum number of clusters. The elbow curve helps us find the optimum value of clusters. The value of k is where the curve bends, is what we looking for, and in our case we have achieved that bend at the value of 3. Now there are certain points which I have already discussed, but we will go on them once again because they are important. The points are: the complexity of a k-means algorithm also increases with increasing k. That is why the choice of k is very important part of this algorithm. Okay, it is very obvious that if we keep on increasing the value of k, our model is going to be better and better and better and better. But the thing is, when you increase k, your computation increases drastically. So you have to achieve that balance. Okay, so too many k, very highly complex algorithm; too less k, very inefficient algorithm. Okay, there is a very significant decrease in accuracy. So the choice in the value of k is a trade-off between complexity and accuracy. So this was about k-means clustering. We have seen how the algorithm works. We have seen how choosing the number of clusters affect our algorithm. We have seen how to get the optimum number of clusters. The next thing that I have on k-means clustering is actually the Python implementation of this k-means clustering. And I will be finding a way to share this code through the YouTube description. And for the next video, we are going to discuss about hierarchical clustering. We will discuss hierarchical clustering, but before I end this video, I just want to show you something. So this is a link that you can note down, or I'll provide in the description of this video. And this is a website which provides us a very good visualization for a k-means clustering. So suppose we are choosing Centroid. I'll restart this. Okay, so this is our initial data points, and we have to form clusters here. Suppose we will be forming 5 clusters. Okay, so first we have here, second we have here, third we will have here, fourth here, and then we have fifth here. Okay, we are going to have 5 clusters. Now the first thing that happens in k-means clustering is the calculation of distance of each point from each centroid, right? So we'll start the algorithm. First thing, all the points have been assigned to their respective clusters. Then we update the cluster. We have updated the clusters, and now we will reassign the points. Okay, so now we can see that this point is now lying in this particular cluster. So we'll reassign the points. Then we will update centroids again, and this is an iterative process. Okay, and this will go on. This will keep on going on until we can see that there is no more transition, there is no more migration between the clusters of data points, right? So when we see that there is no more transition, now we can say that our clusters have been formed successfully, and these are the clusters that we have formed. And this also contains a lot of theory about k-means clustering. So this is a very good link. You can check it out. You can have some fun with it. So this was it. In the next video, we are going to discuss about hierarchical clustering, and yeah.